Right now, you are sitting near something solid, a desk, a phone, maybe a wall, and you've never once thought about why it is solid. You've just accepted it. But here's the thing. The reason your hand doesn't pass through a table is one of the weirdest stories in all of physics, and almost everything. You were taught about it in school. Wrong. Let's start at the beginning. Back in the early 1800s, a chemist named John Dalton proposed something radical, that everything around us is made of tiny particles called atoms. 2 centuries later, we still think he was right. But here is how impossibly small atoms actually are. Imagine a table, but 1 billion times bigger. At that scale, atoms would be the size of melons. You can picture that. But even then, the nucleus at the center of each atom, still too small to see, and the electrons around it, even smaller. So the table you are sitting at right now is almost entirely empty space. So if atoms are mostly empty space, why doesn't light just pour right through your table? And why can't you push your hand through it? The answer is electrons, but not the electrons your teacher drew on the board. You know, that classic picture, little dots orbiting a nucleus, like planets around a sun. That is a useful cartoon, but it is not the truth. Think of electrons more like a flock of starlings. Thousands of birds moving so fast you can't track any single one, but the whole flock has a shape, a pattern, and that pattern is real, even if the individuals are a blur. Now here is where it gets poetic. Physicists say electrons dance, not randomly. It is more like ballroom dancing. They follow specific mathematical patterns described by an equation named after Erwin Schrödinger. Some electrons do a slow waltz, low energy, close to the nucleus. Others do something more like a wild Charleston, fast, energetic, further out. Each electron locks into one pattern at a time. And here is the crucial rule. No 2 electrons in the same atom can do the exact same dance. Physicists call this the Pauli Exclusion Principle. Every slot on the dance floor can only hold one dancer. So what does dancing have to do with your table stopping light? When a beam of light hits the table, the electrons grab that energy and jump up to a faster dance pattern. Because this is happening across trillions of atoms simultaneously, almost no light makes it through. The electrons absorb it. Then, after a tiny fraction of a second, the electrons release that energy, sometimes as light again, bouncing back toward your eyes. The specific patterns of which light gets absorbed and which gets reflected. That is where color comes from. The electrons are choosing what you see. Now here is the part that completely floored me. Why does the table feel solid when you touch it? Most people say it is because negative charges repel each other. Popular answer. Not the full picture. The real reason. The dance. Again, when your finger presses the table, your finger's electrons get close to the table's electrons. Some of your electrons want to move into a dance slot around the table's nucleus, but that slot is already taken, so they're forced into a higher energy, unoccupied slot. That costs energy. For 2 atoms, the cost is tiny. But when you are pushing billions of finger atoms against billions of table atoms, the total energy required is enormous, more than your muscles can supply. That resistance you feel, that is quantum mechanics pushing back. The table isn't solid because it is dense. It is solid because the math of electron behavior makes it impossible for atoms to share space. So next time you put your phone on a desk or lean against a wall, you are not experiencing something ordinary. You are watching one of the most elegant rules in the universe play out in real time. Quantum mechanics, keeping the world from falling through itself. If that kind of thing keeps you up at night, the good kind, hit subscribe, drop a comment. What everyday thing do you want us to really explain? Because I promise the real answer is almost always stranger than you think. See you in the next one.